Hello friends! Jen Foxbot here for another edition of Math Mondays. Da-na-na-na-na. Yeah! Math is so exciting! I'm so glad you joined me today. We are going to be resuming our exploration of Algebra 2. So in attempting to focus on the things that are challenging and fundamental, in this episode we're going to cover the distance formula and midpoint formula. So here we go. Let's start with a simple example. So on the horizontal axis I have my x, and on the vertical axis I have my y. And these variables could be anything, but since it helps to build an understanding using concepts that we're familiar with, let's talk about actually traveling. And so in that case, I'm going to say that the units on both of my axes are in meters. Sorry, US folks, I really like the metric system. It just works better. Let's start with this simple example. So if I put my house at the origin, which we can set as 0, 0, then I walk to the coffee shop, which is, it's not actually this close, but let's say it was 5 meters away at a location of 5, 0. And then I want to know how far did I travel to go to the coffee shop? And we're like, oh, I got this. We traveled 5 meters. Because we know that we started at 0, 0, we ended at 5, 0, and the distance that we traveled was just 5. Well, what are we doing when we are making this calculation? We're actually saying, well, okay, our final position was 5, our initial position was 0, and so the change in position was 5 meters. Pretty straightforward. And then we could say, okay, well, let's say I walked to the library next, which was at a position of 10, 0, and I wanted to know how far did I go to this second location? I'm going to call this distance 1, and this is distance 2, or D1 and D2 for short. And so this is D1. And so with D2, since we're not starting at the origin, we have to subtract this distance because we don't want it to count. We're only interested in this distance. So we want to remove this distance, which we do by saying, oh, well, 10 minus 5, that's a funny 5. 10 minus 5 is 5 meters. So turns out it's the same distance between my house and the coffee shop and the library. Pretty straightforward. But let's be real, we very rarely walk in a perfectly straight line. The world that we live in is three-dimensional, or at least the world that we experience is three-dimensional. Four-dimensional, I suppose, if you count time. We're keeping this simple. And so it's very unlikely that I would just be able to walk in a perfectly straight line in one direction and get to where I wanted to go. A more realistic scenario is that I would be walking in both directions. Probably not equal distance, depends, maybe you do. If you're lucky enough to be able to walk across the street or whatever, if you want to do some parkour and just go in a straight line. Oh, uh-oh. Oops, sorry for that little pause, my dog wanted to say hello to somebody outside the door. Anyway, okay, so let's say you wanted to go in a straight line, assuming you have permission from folks, and you end up at your friend's house, which is 5, 5. And so then you want to say, okay, well, how far did I travel from my house at the origin to my friend's house, which is located at this position on my personal coordinate map? So in this case, it's a little bit more tricky because we're traveling in 2 directions. But here is the trick. We can create a right triangle by finding the distance that we traveled in one direction, in the x direction, and then by finding the distance we traveled in the y direction, and then we can just figure out what the hypotenuse of that triangle is, and ta-da! That's the total distance that we traveled. Okay, so really quick review. The hypotenuse of a right triangle is equal to a squared plus b squared. That's the whole c squared thing, where c is the hypotenuse. And so c is the square root of a squared plus b squared. It is possible to derive this formula. At this point, I'm assuming or hoping that you know it. If you don't know it, that's what it is. If you want me to derive that formula, let me know, but not in this video. Anyway, so that is the hypotenuse of a right triangle. And so in this case, the sides of our triangle are the distance that we traveled in the x direction and the distance that we traveled in the y direction. So the bottom of our triangle is 5 meters, and the height of our triangle is also 5 meters. And so in this case, we can say, okay, well, the hypotenuse of our triangle is the square root of 5 squared plus 5 squared, which is going to be 25 plus 25, which is going to be 50. And then we add our units because we are good mathematicians. And we say, okay, well, we traveled a distance of the square root of 50 meters, which is something like 5 root 2, whatever. We don't need to simplify this. But you can use a calculator to figure out what the distance is in decimal form. So then we're like, cool. Now I know how far it is to get to my friend's house if I'm able to travel in a straight line. But let's do the exact same thing here, because since we started at the origin, we didn't need to subtract any distance from our path. Let's say we travel in another straight line to the library, because yay, libraries, and it happens to be at a position of 10, 10. And then we want to say, what is the second distance that we traveled? Well, we do the exact same thing. I'm going to move that because it's kind of in the way. We'll rewrite that here. This is 5, 5. So in this instance, we need to find the base and height of a right triangle that is right here. So you can see that it makes a bigger right triangle with a base of 10 and a height of 10, but we don't care about the total distance at this point. I want to know what is the distance between my friend's house and the library. Since I picked an easy example, you could be like, well, it's the same distance because you're just doubling it. It's like, touche, yes, you can say that. But if I had picked a harder example, we can't use our intuition, we might actually have to calculate it. And so let's use this simple example to match our intuition with the calculation. So in this case, we basically have to subtract the distance that we already traveled, because we don't care about that yet, or at least we don't care about that right now, and then find the distance that we traveled from our starting point to our final destination. Oh, that sounds a little ominous. My final destination is the library. That sounds better. So in this case, we can draw this down farther and say, okay, well, I want to find the length or the distance between our initial starting point in the x direction and our ending point in the x direction. And since this is 10, I would do 10 minus 5 and figure out that that's 5. Same thing here. I want to find the change in position from my starting point at 5 to my ending point at 10, and we would say, okay, well, 10 minus 5 is 5. So let's generalize that and say, okay, well, if I want to find the hypotenuse of this new triangle, I need to subtract the starting point from my ending point for each of the directions. And so what that is what that is going to look like in one formula is 10 minus 5 for the x direction plus 10 minus 5 squared in the y direction. And so if I were to generalize this, I would notice that this is x2 and this is x1, where this means this is the ending point in the x direction, and this is the starting point in the x direction, sorry. And this is the ending point in the y direction, and this is the starting point in the y direction. And so we can solve that. I leave that challenge to you because you're totally capable. And so what we would find for a general formula is that the distance between 2 points is going to be the square root of the final position in the x direction minus the initial position squared plus the final position in the y direction minus the starting position in the y direction. Ta-da! And so this will work for any pair of coordinates in a two-dimensional coordinate system. Let's look at a little bit more complex example and apply this, and then we will talk about the midpoint formula. All right, so in our final example of the distance formula, we're gonna have x and y again. We'll keep it rooted in our experience and say, again, my house is at 0, 0, but let's say I started the day at a friend's house, and that friend's house was located at 2, 3, and then I went to brunch at a place that was at, I went to brunch at 7-Eleven, maybe. So this is our starting point, and this is our ending point, and I want to find the distance that I traveled between where I started and where I ended. And so to do that, we use the distance formula that we just figured out, and we say, okay, so I subtract the position I ended at in the x direction, which is 7. I subtract the initial position from the final position, so 7 minus 2, and I square that, and then you add the change in position between the starting point and the ending point. So you have to subtract where we started from where we ended, which is going to be 11 minus 3. You square that. And then we simplify this. 7 minus 2 is 5. 5 squared is 25. 11 minus 3 is 9. 9 squared is 81. 25 plus 81 is 106. And then, like good mathematicians, we add our units on at the end. Cool. All right. So that is how far we traveled from our starting point to our final ending point. I don't like saying final destination. It does sound pretty ominous. Cool. So that is the distance formula. Pretty straightforward when we actually understand what we're doing. All we're doing is making a little triangle. Yay. All right. So to end, let's say that for some reason I wanted to know what the midpoint of my journey was. So I'm going to call this M. What is the midpoint of the distance that I traveled? So in a, I'm going to erase this for a little bit more space. So if we were to do this in one direction, and let's say I traveled to 3, 0, and I asked what's the midpoint of my journey, you would say, oh, well, 3 divided by 2 is 1.5, so the midpoint would be, or the halfway point would be 1.5 meters. Yeah, pretty straightforward, right? But what if I said that I started at 1 and I ended at 4? Let's erase this to keep it simple. And I wanted to know if I started here and ended here, what is the halfway point on the coordinate system? So to build up an understanding, let's do this in a way that I think makes intuitive sense. So the first thing that we would do is we'd say, okay, well, since I didn't start at 0, 0, I have to subtract this chunk because I didn't travel that. So I have to get rid of it. So I would say, okay, well, 4 minus 1 is 3. So the distance that I traveled was 3 meters. And then you would say, oh, well, the halfway point is just 3 divided by 2, which is 1.5 meters. But that's the halfway point here, and that's assuming we could say 1.5 meters if we'd started at the origin, but now we have to add back what we already traveled so that we can get the coordinate of the halfway point. And so we say, okay, well, now we need to add back 1 meter because we didn't travel that, and then we get 2.5 meters. So the halfway coordinate is going to be 2.5 comma 0. Ta-da! Okay, but that had a lot of steps in it. How do we condense that equation and generalize it for whatever circumstance that we might have? Okay, well, let's look at what we did here and combine the pieces. So basically, I'm going to give myself a little more space. So what we did is we said 4 minus 1 divided by 2 plus 1. And what I'm going to do to generalize this equals the midpoint, is I'm going to write this in terms of coordinates. So 4 is x2, 1 is x1, and so we did x2 minus x1 divided by 2 plus x1. So if I want to bring x1 into this fraction, I need to multiply it by 2 over 2. And remember, 2 over 2 is just 1, so our equation actually stays the same. We're just rewriting it in a different way. And then we can say, okay, x2 minus x1 plus 2x1 over 2. And we're like, oh, hey, whoops, that's x1. Look at that. 2x1 minus x1 is just x2 plus x1. Look at that. Haha. Cool, right? So this is the midpoint of our travels in the x direction. And so if we want to generalize that, then we can do the same thing if we were to travel in the y direction or if we were to travel in a combined direction. And so we would get that the midpoint formula is x2 plus x1 over 2, comma, y2 plus y1 over 2. Boom. Cool. So my challenge to you is to find the distance formula, or the distance, and the midpoint of the coordinates. Let's say you start at, I don't know, 7 comma 12, and you go to 13 comma 27. Ha! Good numbers. So what is the distance between these two coordinates, and what is the midpoint of the distance that you traveled? Okay, please let me know if you have any questions about any of the things that we covered in this video. Or, of course, if you have questions about particular math topics, I'd be happy to tackle them with you. Thank you very much for watching, and we'll see you next time. Bye!